ವಿಜ್ಞಾನ ತರಗತಿಗಳು @VSR ಯೂಟ್ಯೂಬ್ ಚಾನೆಲ್ಗೆ ನಿಮಗೆ ಸ್ವಾಗತ. ವಿಡಿಯೋ ನೋಡೋಕ್ಕೂ ಮುಂಚೆ ಚಾನೆಲ್ ಅನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಮತ್ತು ಲೈಕ್ ಮಾಡೋದನ್ನು ಮರೆಯಬೇಡಿ. ನಿಮ್ಮ ಲೈಕ್ಗಳು ಉತ್ತಮ ವಿಡಿಯೋಗಳನ್ನು ಮಾಡಲು ನಮಗೆ ಪ್ರೇರಣೆ ನೀಡುತ್ತವೆ. ಲೈಕ್ ಮಾಡ್ತೀರಾ ತಾನೇ? ಡಿಸ್ಕ್ರಿಪ್ಷನ್ನಲ್ಲಿ ಈ ವಿಡಿಯೋಗೆ ಸಂಬಂಧಪಟ್ಟ ಮಾಹಿತಿ ಇದೆ, ಡೌನ್ಲೋಡ್ ಮಾಡಿಕೊಳ್ಳಿ.
Hey there, and welcome. Today, we're going to get into the absolutely incredible science behind the food that's on your plate. You know, from the crunchiest apple to the fluffiest bread, there's a huge history of innovation that has shaped everything we eat. So, let's dive right in. I mean, really, have you ever just stopped and thought about it? Why are the strawberries you buy today so much sweeter, so much bigger than the ones your grandparents might have eaten? Well, the answer isn't magic. It's agricultural science. And it's a story we really need to understand, especially when you look at the challenges that are just around the corner. Because this number, this is the big one. By the year 2050, this is how many people our planet is expected to be supporting. That's over 9.5 billion mouths to feed. And that single massive number, it's the central challenge that drives scientists and farmers to constantly, relentlessly improve our crops. But you know, it's not just about growing more food. We have to do it on a planet that's facing some pretty serious environmental pressures. It's this incredibly complex equation with a whole lot of moving parts. Think about it. Our crops are in a constant battle. They're up against totally unpredictable weather, crazy droughts one year, massive floods the next. There's always a new wave of pests and diseases, and our soils are losing vital nutrients. And then, on top of all of that, we, the people buying the food, we're demanding stuff that tastes better, lasts longer, and is way more nutritious. That is a huge ask, right? So how in the world do we create crops that can handle all that? Well, let's start with the oldest trick in the book. This is a method that humans have been using for literally thousands of years. It's called selective breeding, and honestly, it's brilliant in its simplicity. You just find a plant that has a trait you really like, maybe it grows the biggest fruit, and you find another one that's super tasty, you breed them together, and you cross your fingers, hoping their kids get the best of both. And get this, our ancestors were doing this long before they had any idea what genetics even were. The whole thing is a slow and steady cycle. First, you identify what you want. Then you pick the parents, you cross-pollinate them, and then you grow the kids and see what you got. You pick the very best of that new generation, and then you do it all over again, and again, and again. Over many generations, those traits you want become more and more common. That's a perfect way to think about it, isn't it? You're basically a coach, constantly scouting for the best performers and building an ever stronger team. It's kind of like nature's version of a sports draft. Okay, so selection is powerful, but it's a bit of a slow burn. What if you could be more targeted? What if you could intentionally combine the strengths of two very different plants to create a sort of super offspring? Well, that's exactly where hybridization comes in. The key phrase here is genetically different. You're not just picking the best from a similar group of plants anymore. Now you're taking two totally distinct varieties, each with its own special superpower, and you're engineering a cross that packs all of that into one powerful new package. And this chart here just lays it out perfectly. Okay, so look at parent A. It produces a ton of grain, but wow, it gets sick really easily. Then you've got parent B. Doesn't produce a lot of grain, but it is incredibly tough against diseases. So what happens when you cross them? You can get a hybrid kid that gets the amazing high yield from parent A and that tough disease resistance from parent B. You literally get the best of both worlds. Now here's where it gets really cool. The result of that process leads to this thing called hybrid vigor. It's this incredible biological bonus where the hybrid child isn't just a simple average of its parents. It's often healthier, bigger, and way more productive than either one of them. It's like 1 + 1 = 3. So selective breeding and hybridization are amazing, but they do rely on the genetic traits that nature happens to give you. Modern science started asking a new question. What if we didn't have to wait? What if we could create new traits on demand? This is where we learn how to speed up nature. So one of the most fascinating modern techniques is called mutation breeding. Now hang on. Mutations happen naturally all the time, right? It's the engine of evolution. It creates genetic diversity. But waiting around for a really useful mutation to just pop up on its own could take, well, centuries. With mutation breeding, scientists use tools like radiation or certain chemicals to safely cause thousands of random genetic changes all at once. It's like taking a deck of cards and shuffling it at hyperspeed. And out of those thousands of new variants, breeders can find a few with brand new, super useful traits that might have never appeared otherwise. So when you lay it all out like this on a timeline, you can really see the whole story of innovation. I mean, we spent thousands of years just picking the best plants. Then, a couple hundred years ago, we got really smart about hybridization. And in just the last century, we developed things like mutation breeding. The pace of change is just accelerating like crazy. So here's the most important question. What does all this science actually mean for us? What are the real-world results of thousands of years of improvement? The results are, in a word, staggering. Just look at the global cereal yields. The amount of grain we can grow on the exact same piece of land has absolutely skyrocketed over the last 60 years or so. That incredible increase, it's a direct result of us breeding better, stronger, and more productive crops. And it's not just about quantity, not just about getting more food. This science delivers so much more than that. It gives us crops that can fight off diseases, that can survive with less water, that provide more vitamins, and yeah, even taste better and last longer in your kitchen. Every single one of these improvements helps build a tougher, more reliable food system for all of us. At the end of the day, that's what it all boils down to. This isn't just science for the sake of science. This is practical, absolutely essential work, using our knowledge to solve one of the biggest challenges humanity has ever faced, making sure everyone has enough to eat. And that leaves us with one last thing to think about. As our population keeps growing and our climate keeps changing, the pressure to innovate is only going to get more intense. So what new traits will our crops need in the future? What will the food of tomorrow actually look like and taste like? The story of how we improve our food, well, it's far from over.